Hello, today I'll be presenting on the workings of large language models and their various practical applications. We'll start by exploring data collection and preprocessing and delve into the model's architecture, the training process, methods for evaluation, and finally, we'll examine real-world applications such as voice cloning and translation. First step in training large-scale language models is collecting a wide range of textual data. Data can be obtained from various sources such as books, papers, websites, and social media. Subsequently, the collected data undergoes a preprocessing phase to transform it into a suitable format for model training. During text cleaning, unnecessary characters and words are removed, and tokenization is performed to split the text into individual words. Following that, each token is assigned a unique numerical ID through vocabulary indexing. Lastly, in the data quality improvement phase, the data imbalances are addressed, and missing data is handled to prepare a refined and structured data set suitable for model training. Now, let's take a closer look at the structure of the model. Most large-scale language models are based on deep learning architecture, with the transformer architecture being widely used. The transformer architecture consists of encoder and decoder blocks, each containing self-annotation mechanisms and position-wise feed-forward networks. These models can have hundreds of millions or even trillions of parameters, which are crucial for the models to learn complex patterns and relationships from data. The model processes tokenized text data, where each token is transformed into a high-dimensional vector through an embedding layer. These vectors are then processed in different layers of the model, allowing it to understand the meaning and structure of the text. Now, let's delve into the training process of the model. The training of large-scale language models is typically divided into two major phases: pre-training and fine-tuning. During the pre-training phase, the model learns basic language understanding by utilizing a vast amount of text data. This phase is primarily conducted through unsupervised learning. In the fine-tuning phase, the model is tailored to specific tasks or domains using a similar amount of labeled data. This involved supervised learning. The objective throughout the training process is to minimize a loss function. To achieve this, optimization algorithms such as ADAM or SGD are employed. The learning rate determines the speed of model training, while regularization techniques are used to prevent overfitting and enhance generalization performance. These training strategies play a significant role in shaping the model's performance. Now, let's explore the evaluation process. During the evaluation phase, the goal is to assess how well the trained model performs. This involves measuring its performance using various performance metrics, which are quantitative measures of how accurately the model is making predictions or classifications. Common performance metrics include accuracy, precision, recall, F1 score, and more, depending on the specific task. To ensure a comprehensive evaluation, validation data sets are used. These data sets are separate from the training data and serve as a benchmark for the model's performance. They consist of data that the model has not seen during training, making them a good indicator of the model's ability to generalize to new unseen examples. Cross-validation techniques are also employed to further validate the model's performance. Cross-validation involves splitting the data set into multiple subsets and training and evaluating the models multiple times. This helps in assessing how consistent the model's performance is across different subsets of the data. providing insights into its robustness. Finally, large-scale language models can also be applied to real-world problem-solving, such as voice cloning and translation. Voice cloning involves mimicking the voice of a specific individual to generate new sentences. Language models play a role in this by being a part of text-to-speech synthesis systems that convert text into speech. In the field of translation, language models function as a crucial component of machine translation systems, translating text from one language to another, especially translation systems based on the transformer architecture leverage the language understanding and generation capabilities of language models to provide accurate and natural translation.